Hey guys, probability, best unit of the course, is actually my favorite unit. I know you guys probably don't agree, but that's what we're here for, to help you if you have any questions. I know there are a lot of formulas and things like that. This video might take a while. I mean, if you look, there's over 103 questions on the test 2 reviewed, so we'll just knock it out. Of course, just like the first one, sometimes I don't read questions very carefully because the duration of doing them all kind of gets to be a lot. So at the very end, I do check all the answers, and if there are any mistakes or anything like that I've made, I will definitely talk about them at the end. So let's just get started. Number 1, suppose that the probability of A is 0.96. Which of the following is the best interpretation of this statement? Event A will occur more often than not, but it is not extremely likely. That's not true. Event A is extremely likely. Remember, extremely likely means that the probability is essentially 1, or very close to 1. But in a long sequence of trials, it occasionally will not occur. That's true. In a long sequence of trials, it will not occur about 4% of the time. So same thing with question 2. Exact same answer. There are 42 students in a film production course at GSU, 15 freshmen, 10 sophomores, 13 juniors, and 4 seniors. One student is selected at random to have his film shown at the Rialto in downtown Atlanta. What is the probability that the student chosen is a senior? So, to do this, all we're going to do is say, how many seniors are there? 4. Out of how many total possible seniors? 15 plus 10 plus 13 plus 4. Look at how I type my answer in. Just please use parentheses when you need them. If not, it's going to do order of operations and give you something that's not correct. So, all these are in percent, so we can, what is this? Okay, so we can multiply this by 100 to get to be a percent. Just go back in the code and just do that. And then if we want to round to the nearest whole number, you can see it's going to be 10%, but if you need Excel to do it, there we go. Okay, suppose Joan has a fair 4-sided die with sides that are numbered 1, 2, 3, and 4. After she rolls it 24 times, she finds that she's rolled a total of 4 times. What is the empirical probability that she rolls a 4? So there's 2 different types of probability. There's an experimental probability, what we do when we just roll a die, and 10 times to see how many times we get a 4. But there's also the empirical probability, which is your theoretical probability. You know, there are 4 sides to the die. One of them is labeled a 4, so there's a 25% chance that you roll a 4. It is known that 4% of children carry a certain virus, but a leading health researcher suspects that the percentage is actually higher. Which of the following provides the most convincing evidence to support the researcher's suspicion? Out of 20 randomly chosen children, 1 carries the virus. Out of 60 randomly chosen children, 3 carry the virus. Out of 5,250 carry the virus. Out of 5,000. If you look at all these percentages, let's just do 1 out of 60. Let's go around again. That's 2%. And we suspected it's more, so that's not going to be right. We could do 3 out of 60. Sometimes if Excel does this, just go back and make it a number. Go to this number section and make it numerical. So that's 5%. We can do 250 out of 5,000, 5%, and 210 out of 5,000. But what happens with probability is you want a large sample size. So if we have 5,000 randomly chosen children and 250 of them carry the virus, that's about 5%. It is 5%. So that provides the most evidence that it's greater than 4% because it has a larger sample size. And you can look, the other group of 5,000, the probability was only 0.042. Okay, same question. So I'm going to skip that one. It's the same reasoning as before. But we look, which one's the lowest with the largest sample size? Joan has a four-sided die with sides of numbers 1, 2, 3, and 4. After she rolls it 20 times, how many times does she roll the number 3? I'm going to say it's impossible to tell. We don't know exactly how many times she's rolled the number 3. We can get an estimate for how many times we expect her to roll the number 3, but we can't know exactly how many times. Okay. Same question. After she rolls it 2,000 times, she finds that she rolled the number 2 a total of 187 times. Which of the following is true? Joan has provided evidence that calls into question whether or not this is a fair die, because the relative frequency of rolling a 2 is quite different than the theoretical probability even after repeating the experiment many times. So let's just see. What's the relative frequency? 187 divided by 2,000. 0.09. Yeah. So because she rolled it 2,000 times, 187 out of 2,000, about 10%. You know, you would expect with such a large sample size that your relative frequency would roughly be the theoretical probability of 0.25. You would see number 2 25% of the time, you would see number 3 25% of the time, a 4 25% of the time, and a 1 25% of the time. Therefore, because it only occurred 10% of the time, it probably does call into question the validity or the fairness of the die. A family plans to have 3 children. For each girl, assume that the probability of a boy is the same. Okay, what is the probability that they will have at least one boy and at least one girl? So with questions like this, what you're going to need to do is think about all possible combinations of 3 children in a family. You know, we could have 3 boys, 2 boys and a girl, a boy, girl, boy, or a boy, girl, girl. Assuming that you have a boy first. And then we can do the same thing, girl, 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 boy, girl, boy, girl, girl, boy, boy. And if you look and you count, there are 8 possibilities. And this should make sense because think about your multiplication rule. There are 2 options for the first child, boy or girl. There's 2 options for the second child, boy or girl, and 2 options for the third child, boy or girl, which is a total of 8. So 2 times 2 times 2 is 8. We should have a total of 8 combinations. So what is the probability that they will have at least one boy and at least one girl? So all you're looking to see is how many options here have just a combination of boys and girls. 1, 2, 3, them. That means all girls, and then these 3. So out of this total sample size, or out of this sample space, we have 8 options, 6 of which have at least one boy and one girl. 0.75. A person in a casino decides to play blackjack until he wins a game, but he will not play more than 3. Let W denote a win and L denote a loss. What is the sample space for this? Well, it's almost exactly like what we just did. We're going to play 3 games, and we have 2 options. So we could win, 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 lose, win, lose, win. I don't think 2 commas should be there. But really all you're looking for is there are 8 possibilities. You could win and lose each game, playing 3 games, therefore there's 8 possible combinations. A person is in a casino. Define the event A as the person wins at least 1 game of blackjack. What are the possible outcomes for this event? Well, if we want to win at least 1 game, you can kind of do the same idea with the boy and girl thing. Win, 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 lose, win, lose, win, win, lose, 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 win, lose, win, lose, lose, win, win. And now we're going to say, at least 1 game. We're winning at least 1 game. So that's winning at least 1, 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 that's not. That's winning at least 1, that's winning at least 1, and that's winning at least 1. So, all the ones I just bolded, there are 7 possibilities, and the only one we don't include is lose, lose, lose. So, look and see which one has 7 options. 1, 2, 3, 4, 5, 6, 7. That would be C. A person, it's the same thing. Same exact question. Same with, yeah, it's the same thing. So, same idea, just list it all out. Alright. These ones are tricky. There's a million different ways that we could go about doing 15. I do it a certain way that just allows you to use Excel commands, but I'll show you the another way of doing it too. So a club is choosing 2 members to serve on a committee. The club has nominated 2 men and 3 women. By chance alone, what is the probability that no women are chosen to be on the committee? So what we need to think about is our sample space. We have a group of 5 people that have been nominated, not regarding the gender, just 3 men and 2 women. So the question is, how many ways is it possible for us that out of a group of 5 people, we select just 2 of them? That would be 10. There are 10 possible combinations. And if you hear barking in 2 seconds, it's because my dogs are playing behind me. That's just sample space. So now we have to think about, though, separately, think about the gender part of it now. How many ways are there of selecting the different males and females? So, the club has nominated 2 women and 3 men. Based on chance alone, what is the probability that no women are chosen? That means that out of the group of 3 men, we're taking 2 of them. And out of the group of women, we're taking how many of them? None. So, out of the 2 women, selecting 0. So that means, take out our probability, think about your multiplication rule, how many ways are there of selecting both males and females in this way? That's going to be 3 times 1. Divide that by your sample space. 0.3. And actually, that's, you don't need to worry about it. If you want to make it 4 decimal places, go for it. There is another way you can do it without using those combinatorics formulas, but it requires a little bit more thinking, I think. What we have is a group of 5 people, and based on chance alone, what is the probability that no women are chosen? That means the first person that we choose is going to be a male. So, out of the 5 people, 3 are men. So we can look at that probability, and then say, think of it like a conditional probability, conditioned on the fact that we've already selected a male, what's the probability of selecting another male? Well, that would be there are 2 men left out of 4. And then just, there's your 0.3 as well. But the thinking behind this gets to be a little bit much when you're asking for like 1 woman or something like that, because then you have to think about, or probability, which is why I prefer it this common way, because it works every single time like that, and it's kind of straightforward. An iron contains 14 red marbles, 22 blue, and 36 yellow. 1 marble is chosen at random without looking. What is probably that it's a red or a blue? Well, this is pretty easy, because all I think about is how many marbles in the bag are red or blue? Well, he has 14 red and 22 blue. And we just divide that by the total number. 14 plus 22 plus 36. 14, 22, 36. 0.5. Let me make sure that it's nothing weird. I don't know why. It should just be 0.5. There you go. Alright. A fair die is rolled 12 times. Which of the following is most likely outcome? Well, when it comes to rolling a die, every single face has the same chance of being selected. It's a 1/6 chance. So we could find the probability of rolling this sequence by just doing it 6 times a 6 times a 6 times a 6 times a 6, 12 times. So it's 6 to the 12th. But if you do that for all 4 possibilities, you get the same probability at the end. It's unlikely that you would get, it seems unlikely that you would get a complete string of 6s, but actually, theoretically, they have the same chance of occurring, because every single roll is independent of the other one. So actually, the answer to this is a trick question. They're all equally likely. Same thing with this. Flipping a coin instead. They have a half chance of being selected, but it's the same thing. Each flip is independent of another. The key here is that it's fair. So all of these each event has a probability of 1/2 to the 12th of occurring. In the population, 8% of males have had a kidney stone. Suppose a medical researcher selects 2 males from a large population. Let A be the event that the first male has had a kidney stone, and B represent the event that the second male has had a kidney stone. True or false, they're independent. Independent events mean that, let's save it really quick. When you get that message saved. Because I don't know, I feel like after a certain amount of time, to be honest with you, I think your answers might disappear because it might not submit everything. But the answer to this question is, so just as I said in the last video, please save as much as possible, even when you're taking your test. So the probability, or the two events in question here are independent, meaning one does not affect the other. The occurrence of one does not affect the occurrence of another. And this should make sense. I mean, if I have a kidney stone, somebody that works with me having a kidney stone, I'm not going to affect that. The fact that I have one is not going to affect that. Same thing with this one. And another key part of this is that it's from a large population. Same question here, but now we're talking about diabetes. They are independent. Me having diabetes is not going to affect you having diabetes. Okay, this question's hard. Not hard, just you got to think about it a little bit. For safety reasons, 3 different alarm systems were installed in the vaults containing the safety deposit boxes at the Beverly Hills Bank. Each of the 3 systems detects theft with a probability of 0.8, independently of the others. The bank obviously is interested in the probability that when a theft occurs, at least one of the 3 systems will detect it. So, what is the probability that when a theft occurs, at least one of the 3 systems will detect it? So, think of it like this. We could have someone break in and none of the systems detect it, one of the systems detect it, 2 detect it, or 3. Can't do more than that because there's not more than 3 alarms. Not detecting it is bad. So what you're hoping for is if there are 3 alarm systems, at least one of them will detect it. Well, another way of writing these is in terms of, we say 1, 2, and 3. If we add the probabilities together, that's going to be the probability that x is greater than or equal to 1. This is still x equals 0. Let's just think of it as the probability of x equals 0. But what we know, though, is that all of these probabilities, the probability that x equals 0, the probability that x is 1 plus the probability that x equals 2, and the probability that x equals 3, adding them together, we get a total of 1. So the probability that x equals 0 plus the probability that x is greater than or equal to 1 equals 1. And this is what at least means. If we say at least 1, we mean greater than or equal to 1. We'll just solve the equation. Move the probability that x equals 0 to the other side. It's a complement. So the probability that x is greater than or equal to 1 is the same thing as 1 minus the probability that x is 0. So this is the probability that we're going to find. We're going to evaluate this in this way. We're going to do 1 minus the probability that no detection occurs. So what is the probability that no detection occurs? X is 0 means none. Well, what is the probability that no detection occurs for one system? Well, if it detects it with probability 0.8, that means it does not detect it for 1 minus 0.8. But that's for one system. And each system operates independently of the other one, and that's the key here. Because then, to get the probability that no detection occurs for 2 of the systems, we just multiply 0.2 times 0.2. For 3 systems, we just multiply 0.2 times 0.2 times 0.2, or 1 minus 0.8 to the third. And then all we have to do to get at least 1, if you look above, it's just 1 minus this answer. And we want to round to 5 decimal places, 0.99200. And that's what's tricky about this, though, is that you have to consider when we talk about at least one occurring, it's easier to think about it in terms of its complement of 1 minus no detection occurring. Okay? According to the information that comes with a certain prescription drug, when taking this drug, there's a 21% chance of experiencing nausea and a 50% chance of experiencing decreased sexual drive. The information also states that there's a 14% chance of experiencing both. So what is the probability of experiencing neither of the side effects? Well, that means neither is 1 minus the probability of either. And we have to figure out, how do we determine the probability of either event occurring? Well, that means nausea or a decreased sexual drive. So we can just do the OR rule, where we have the probability of either nausea or decreased sexual drive is the probability of nausea plus the probability of decreased sexual drive minus the probability of their intersection. That's an equal sign. That's why. And now we're given all those probabilities. So it's 1 minus. The probability of nausea is 0.21. The probability of decreased sexual drive is 0.5. And there's a 14% chance of them occurring together. 0.43. Next one. According, blah, 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 same question, but now this one says, what is the probability of experiencing only nausea? Now you might get confused and say, well, isn't that just 25%? Because you know the probability of nausea is 0.25. But this 0.25 also takes into account that sometimes you'll experience the decreased sexual drive. And what it means by only nausea means nausea only without any decreased sexual drive. So to get this probability of only nausea, so nausea and not decreased sexual drive, we're going to take the 0.25 and just subtract the chances of it occurring with decreased sexual drive, so 0.10. And question 24 is actually the easiest one, because we can just straight up plug and chug. We want nausea or decreased sexual drive. And we know that that's going to be the probability of nausea plus the probability of decreased sexual drive. Let's subtract what happens when they occur together. 0.53. So let A and B be two independent events. If the probability of A is 0.5, what can you say about the probability of A given B? If they're independent, the fact that B has already occurred should not matter. Therefore, it's equal to the probability of A. 0.5. Suppose a basketball team had a season of games with the following characteristics. Of all the games, 60% were at home, denote this by H. Of all the games, 25 were wins, denote this by W. Of all the games, 20% were at home wins. That means they won given they were at home. Of the at-home games, we are interested in finding what proportion were wins. Which of the following probabilities do you need to find in order to determine the proportion of at-home games that were wins? So, with this question here, let's see. Which of the following probabilities do you need in order to determine the probability of at-home games that were wins? So, we need to look at, let's see, no. Think about your generalized multiplication rule. But we're going to need, I'm reading, sorry, hold on one sec. Alright, so with this one though, we're conditioning on that we're wins. So we're conditioning upon the at-home game. So given that we're at home, what's the probability of winning? Which is all we need. That's what we're trying to find. Okay. Suppose your friends have the following ice cream flavor preferences. They like chocolate, sprinkles. 25% of your friends who like chocolate also like sprinkles. Which of the following do you need to find in order to determine the proportion of friends who like chocolate that also like sprinkles? Well, we would need the probability who like chocolate, but also given sprinkles, probability of chocolate given that you like sprinkles. Well, that's going to be the probability of chocolate and sprinkles over the probability of sprinkles. So that's going to be chocolate given sprinkles. So let A and B be two independent events. If the probability of B is 0.5, what can you say about the probability of B given A? Well, they're independent. So the fact that A occurred does not change the probability of B. So once again, like the one before, it's equal to 0.5. Two methods A and B are available for teaching a certain industrial skill. There is an 80% chance of successfully learning the skill if method A is used, and a 95% chance if method B is used. However, method B is substantially more expensive and therefore used only 25% of the time. Method A is used 75%, okay? The following notations are suggested. Method A is used A, B, okay. Which of the following is the correct representation of the information that is provided to us? So, probability of A is 0.75, probability of B is 0.25, that's good. Then the probability of L of success given A is 80. And method B is, I think, if method B, that seems right. Let's look. Yeah, I think that's right. So the probability of learning it successfully given that A occurred is 80% chance. Yeah, I'm going to stick with this one. Which of the following is the probability that a die toss will be less than 4 given that it is odd? The probability is B given A. Let me see something. I feel like there is a question missing on this. There it is. Alright. Okay. Next one. Of the friends who like sprinkles, what proportion of this group like chocolate? So what this question is implying is we want the proportion who like chocolate given sprinkles. So we're going to say that this is the probability of chocolate and sprinkles, 0.16, divided by the probability of liking sprinkles, 0.16 divided by 0.43, 0.3721. Alright, of the at-home games, what proportion were wins? So, the probability of winning given H, which is winning and H. So what's the probability of being at home and winning? 0.2, divided by the probability of being at H, 0.6, so 1/3. 33. Alright, so we have Dalmatian Study. 31% of all Dalmatians have blue eyes, 38% of Dalmatians are deaf. If a Dalmatian has blue eyes, there's a 42% chance that it is deaf. Based on the results of the study, is having blue eyes independent? No. Because if it has blue eyes, there's a 42% chance that it's deaf. Well, if it were independent, the fact that it has blue eyes would not alter the probability of it being deaf. And it goes up from 38 to 42%. So no, they are not independent. Those of the handedness of the last 15 U.S. presidents are as follows. 40% were left-handed, 47% were Democrat. If a president is left-handed, there's a 13% chance that it's a Democrat. Is being left-handed independent of being a Democrat? Well, no. Because if they're independent, the probability of being a Democrat will be the same, but 47% is not equal to 13%. Okay? Okay, so this question here is going to require that generalized multiplication rule. So we say the probability of A given B equals the probability of A and B divided by the probability of B. Well, we can reorder that and just say the probability of A and B is equal to the probability of B times the probability of A given B. Just reword this formula. Ooh, let me think. Come on. All right. Okay, so then we have all this information. We know that the probability of, think of it like this, let A and B is the event of blue eyes, and A is the event of being deaf. So we want A and deaf, we want the probability of blue eyes times the probability of, if they have blue eyes, there's a 42% chance. Probability of blue eyes times the conditional probability, like 1302. And this is going to be the exact same one. What is the probability that a randomly chosen U.S. president is left-handed and a Democrat? Use the same reasoning behind this question here. Just reorder your conditional probability and get that generalized multiplication rule. Consider the following statements about a particular traditional class of statistics related to, okay? The number of students in the class is a discrete. Remember, discrete variables are ones that you can like just count. 1, 2, 3, 4. If it takes on any sort of value in an interval, then it's called continuous. You know, heights are referred to as continuous because we can measure someone's height in inches, feet, centimeters, meters, and we can always get finer and finer and finer measurements. So this is discrete. The average age of students is continuous. That's not true. The room number is continuous. That's not true. The average weight of a student is discrete. Now, weight is also generally referred to as a continuous random variable because we can always get a finer and finer and finer estimate of someone's weight by increasing the decimals. So really, that's the only one that's discrete. That's the only one that's true. Alright, which of the following are true? The batting average of Joe's favorite player is a continuous variable. I'm going to go ahead and say that is probably, I'm going to say that's true because we could probably, to decimal, we could probably get finer and finer estimates of that batting average. The number of hot dogs is discrete. The number of strikeouts is not discrete. The Quake standing in the league is discrete. Yes. Which of the following are discrete? We could say shoe size would be discrete. A waist measurement, probably not. Dress size. I'm going to say those two, because foot length you can kind of, just like height, measure it finer and finer. Waist measurement, same thing. Shoe size, just because of the way that we measure shoes, it's like 10, 10 and a half, 11, 11 and a half. It doesn't get any finer than that. And same thing with dress size. I think dress sizes are like 0, 1, 2, 3, 4. I think it's like that. Which of the following is a characteristic of a discrete random variable? It's something that you can count. Really. Something you measure is more continuous. Which of the following is a discrete? Not volume. Cards finished. Yeah, weight and height are something you measure. Daily rainfall is an example of what type of data? I'd say it's continuous because you measure that in inches. The number of times that a hiker walks over 8 miles each day is discrete. Okay, now we're at the fun stuff. Let's delete all of this. Man, we still got like 59 questions left. So, what is the probability that on a given week there will be at most 3 accidents? So copy the table into Excel. And all you're going to say is at most 3 means there's no more than 3. So we just look at 3 accidents and less. If you highlight it in Excel, look at it tells you the sum, because that's what we're looking for. At most 3 is 1, 2, 3, and 4. What's the probability? It gives you 0.85. 3.2, 0.15, 0.1. Oh, it's the same. So by the 3rd day of a particular week, 2 accidents have already occurred in the intersection. what is the probability that there will be less than a total of 4 accidents during the week? So we know the probability. We want to find the probability that there's less than 4 accidents, given that we know that at least 2 have occurred. What? And it just says 2 accidents have already occurred. And the reason why we're saying greater than or equal to, because we know that there is a possibility that there's more than 2. So now, this is our conditional probability formula. What's the probability of this equal to? Well, it's the probability that we are greater than or equal to 2, and we're less than 4, divided by the probability that we're greater than or equal to 2. So we can just use a table for this. Between 2 and 4 inclusive of 2, that's going to be the sum of 2 and 3, not including 4, then dividing by the probability that you're greater than or equal to 2, well, that's going to be the sum of greater than or equal to 2 means all 4 of these. 2, 3, 4, and 5. 0.7. According to the Pew Research Center, okay, yep, assuming that the data is accurate and stable, what is the probability that a randomly selected person living in the United States would not identify as Christian? Well, this is really easy, because not identifying as Christian means you identify as, is this condition? Living in the United States would not identify as Christian. Okay, yeah. So that's going to be 1 minus the probability of being Christian. Well, if you look at the table, 1 minus, what are the probabilities? What are the Christian probabilities? Well, 0.466 Protestant, 0.208 is Catholic, and an other. 0.293. Another way of doing that is just add up the probabilities of not being Christian. 0.06 plus 0.233 is 0.293. Okay, this is the same one as before. What's the probability that in a given week there will be at most 2 defects? Well, that's you just adding up these 3 numbers, which is 0.9. 0.5 plus 0.25 is 0.15. Alright, let's see. Assuming the data is accurate and stable, what is probably the random type of Christian living in the United States to identify as Catholic? 0.208. Yeah. And we've already done this question too. It's just a different way of rephrasing it. It's the exact same one that I typed here, so I'm not going to do that one. Yeah, because we have 2 have already been detected, so greater than or equal to 2, less than 4. Same thing. Alright, here we have some histograms. Which of the 3 has the smallest standard deviation? So standard deviation means it's a measure of spread about your mean. So if you have a small standard deviation, more of your data is centered at the mean. A larger standard deviation means more of your data is away from the mean. So if we want the smallest standard deviation, that means we want which histogram has the most data at the mean. Well, our mean here is the center at 3. Histogram 2 has the most data there. That's what this vertical bar represents. So why? Hey now. Okay. What is the probability that in a given week there will be at most 4 items sold? Well, at most means no more than 4. Oh, hello. If that happens, just copy it again. I don't know if you saw really quickly when it was a vertical list. But we want at most 4. Well, that's 4 or less. 0.9. That's what I like about Excel, though, is once you copy these values into Excel, just highlight things. You don't have to worry about formulas for some of these. There are going to be formulas, and we'll get to that towards the end, because that's where I put them, those types of questions. But at most 4 is just 4 or less. Just highlight the probabilities, 0.9. This is the same question as the one that's up here. but now it's going to be greater than or equal to 3, less than 5. Nice. Same question. All right, so mean. This is the next one. Oh, same table. Good. So on average, how many items are sold in a week? So what we're looking for is the mean of this distribution. Let me just say that you highlighting this row and saying that the average is 3 is not correct. All right, a lot of students do that. They just see, oh, I have a number 0 through 6, that's the average of those 3. That's not correct because that assumes that 1, 0, 1, 2, 3, 4, 5, and 6 occur equally likely. But if you look at this table, these don't occur with the same probability. So we have to take into account that a 0 will occur 10% of the time, a 1 will occur 20% of the time, 2 will occur 40% of the time. So our mean is probably going to be somewhere around 2. So to get this answer, though, I made a video in the readings to calculate the mean and standard deviation and variance of a discrete random variable. And so we're just going to use this formula, sum product. We're going to take each value of x, highlight them, and multiply them by the probabilities that they occur and add them together. And that's what sum product does. Think of the two words in there, sum and product. Sum is add, product is multiply. We're going to multiply every value by its probability and add it up. And the mean is not 3, it's 2.2. 0.2, all right, so same question. I'll do it again though, just so you can see sum product. Copy the table. Remember, if it does this, just delete it and copy it again. Sometimes it's weird. If it does it again, try it again. But there we go. So on average, how many accidents are there in an intersection in a week? Well, we're going to find that means the mean. Typically, how many accidents are there? Sum product. Take each x value and multiply it by its probability. 1.8. This should make sense. Look around here. The biggest bulk of probability occurs here. About 70% of your probability is between the values of 0 and 2. All right. Wacky Wanda, or what is it? Wanda's wooden widget. I'm not going to do this one. It's the exact same thing. On average, how many defects are found? It's just the average. So you want to copy that into Excel, just use sum product. All right, so we have some histograms, which has the largest standard deviation. So remember, standard deviation is, on average, how far away are your values from the mean. And we want the largest standard deviation, which means we want more of the data away from the mean. And so of these 3 histograms, our mean is 3, but these 2 vertical bars in histogram Z are the largest. So we would say Z has the largest standard deviation. I'm going to save it right now, just while I'm thinking about it. All right. Where were we? I didn't do that one, I just did this one. 57. That's the same thing. Exact same question, just different. The largest standard deviation is where the values are farthest away from the center. That'll be histogram Z. Yay, we're at the questions I made. So, determine if the following could be a probability distribution for a discrete random variable. If no, state why. All we're looking at when you determine if a table represents a valid probability distribution, all you're looking at is to determine, are all the probabilities greater than or equal to 0? Are all of them less than or equal to 1? And do they all add up to 1? So in this way, we have 4 ninths, 2 ninths, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the numerator is up to 9. Divided by 9 is 1. So they're all positive. They're all less than 1, all greater than 0. And if you add up all these values, they equal 1. Here, is this a valid probability distribution? Well, you can immediately see that the probability that x is 20 is 1.1. That would be no. And also, don't assume that the values have to be like sequential as 20, 21, 22, 23. That was the purpose of this part. The values of x are too far apart. That doesn't matter. Alright, fun stuff. So, using a table to answer questions about probability. What is important with these types of questions, though, is to pay attention to your inequality signs, because that determines if you include that value or not. So the probability that x is less than 2. Well, that's less than 2, not including 2, so that would just be 0.29. Just 1. Greater than or equal to 3. Go to your table, that means we're including 3, and we want 4 and 5. So just highlight that row. You can also, if you want, please know that I'm just doing this highlighting. It's faster, and I'm trying to show you guys ways of testing strategy so you're not swamped with time. But if you want to, just type the word sum, equals to sum, and then we want to add these 3 numbers. 0.3. And it's going to give you a little error because you didn't include the whole row, but you don't need to. But just like I said, if you just highlight them, it's 0.3. 1 is less than x is less than or equal to 3. Well, that means x is between 1 and 3, but not including 1. Pay attention to that inequality. So that means what value is between 1 and 3, not including 1? 2 and 3. Highlight them. The sum is 0.6. Okay, 3 is less than or equal to x is less than 5. Another way of saying that is between 3 and 5, including 3, not including 5. 3 and 4. 0.26. And then less than 3 is less than x is less than 5. Well, it's not including either of those values, so what's the only value between those? 7. Or 7, what the heck? 4 that occurs with a probability of 0.07. Right. Next one. This one's tricky because you have to first figure out what is the probability of the blank. And so from what I said before is that we know all probabilities add up to 1. So all of these probabilities need to add up to 1. So if you highlight this row, and you can highlight straight over that, what am I trying to say? Question mark. Wow. We know that the sum right now is 0.75. We need the sum to be 1. Well, what's the only value that will make that sum 1? 0.25. So I'm going to go ahead and just type this in the table, though. Make all the rest of the calculations easier. And once you fill in 0.25, try it again. Now the sum is 1. So then the probability that x is less than 2 means 0 and 1, not including 2. Highlight that row, 0.63. And just so I can show you again, if you want to, just use the sum function. Equal to sum, less than 2 is just the sum of these two numbers, 0.63, which is the same thing we got before. Less than or equal to 2 is 0, 1, and 2. We're including 2. Highlight all 3 now. The probability goes from 0.63 to 0.88. Greater than 2 means the values of x are larger than 2, not including 2. So 3 and 4. 0.12. The probability that x is equal to 1 or x is equal to 4. So think about your probability of or. That's going to be the probability that x equals 1 plus the probability that x equals 4 minus the probability of being x. So it's probability that x equals 1 plus the probability that x is 4 minus the probability that x is 1 and x equals 4. Well, you might be a little bit confused as to why I typed that last line in there. It's technically the formula, but the chances of being 1 and 4 at the same time can't happen. It's disjoint. Those two events are disjoint. You can't be the number 1 and the number 4 at the same time. So we know that from our probability rules that if two events are disjoint, their probability is 0. So we can just, it's removed. So the probability that x is 1 and x is 4, really can't highlight this one. So the sum of this, comma, and this, 1 and 4. 0.23. And 1 is less than or equal to x is less than or equal to 4. Alright, so between 1 and 4, including both, just highlight all the way. 0.57. And we're done. All right. Let's see if I can solve this. From past experience, a company found that, I'm going to make a table with this one. We know that a company has found that in a carton of transistors, 92% have no defectives, so none, with a probability of 0.92. One defective has a probability of 0.03. Two defective has another probability of 0.03. And then three defective, 0.02. And we don't worry about this last row because it doesn't count. But what we should see is that if we add up all of these numbers, it should add to 1. And so we are looking for the mean and the variance. Well, the mean of a discrete random variable we've already found. It's some product. Now, when it asks you for the variance, though, you do need to find the mean first, because the variance is just a measure of spread about the mean. Same with the standard deviation, it's the square of the standard deviation. So we need to find the means first. So we highlight our x's, comma, highlight our y's, or our probability. So the mean is 0.15. Let's get 4 decimal places. So the variance. There are really 2 ways of finding the variance. I do it one way, and you saw it in the video. Your instructor might do it another way, but they both rely on the sum product formula. So all I do to find the variance is sum product, array 1. That's just a list of numbers, by the way. So start with a parentheses, add 1. To find the variance, one of the formulas says you take all of your x's and you subtract the mean. So highlight your x's and just do minus and click the mean. So it's all the x's minus the mean quantity squared, and you multiply that by the probability. So look at how I typed that in. I highlighted my x's, but I subtracted the mean squared, and then I multiplied that by the probabilities. 0.3075. So just be careful of that. Just be careful of your parentheses. Okay, find the value of the constant k so that the following table represents a valid probability distribution. Then find the probability that x is less than 2. So with this question here, we need, first of all, k has to be positive. Okay, that's just implied. But all the probabilities in a table have to add up to 1. So what this means is that we need to make sure that all of these numbers add up to 1. So 2k plus 3k plus 13k plus 2k. Think of your algebra skills. Or use your algebra. They're all like terms. So 2 plus 3 is 5. 5 plus 13 is 18. 18 plus 2 is 20. So we have, if we add all that, we get 20k equals 1. Solving for k gets us 1 over 20. So that is the value of k that makes this table a valid probability distribution. So we want to know then what's the probability that x is less than 2. So the probability that x is less than 2, well, that's going to be 1 and 2. Well, that's 2k plus 3k. That's 5k. Well, we also know that the value of k is 1 over 20. 0.25. Alright, another one. A florist determines the probabilities for the number of flower arrangements they deliver each day. Find the mean, variance, standard deviation, and we'll do the last one in a second. Alright, the mean, variance, standard deviation. Mean is just some product. So I'm not even going to explain that. We'll just calculate it. Because in order to do the variance, we need the mean. Highlight x's, highlight probabilities. And the mean is 20.71, but let's just see if it's more than that. Nope, 20.71. Now, I know it sounds weird to say that she delivers on average 20.71 flower arrangements each day, but it all is about like in the long run. If she delivers flowers every day for thousands and thousands of days, on average is about 20.71. We don't round these to so just be careful. Variance, so once again, it's going to be some product. Add another parentheses right away, highlight your x's, subtract the mean, close the parentheses and square it, comma, your probabilities. 1.6459. Now, the standard deviation, if you remember, is just the square root of the variance. So we just type it in. Find the variance first, square root it. And in Excel, you just type in SQRT. We want 4 decimal places. 1.2829. And this last question is kind of an extension. Approximately how many arrangements should the floors expect to deliver each week, rounded to the nearest whole number? So in this case, we expect to deliver 20.71 per day, and there are 7 days in a week, assuming that the florist delivers flowers all 7 days a week. So what we're going to do is take 20.71 flowers per day times 7 days to give us the week, which is 144.97, or approximately 145 per week. Alright, colorblindness is any abnormality of the color vision system, well, whatever. Okay, that's a lot of words. Which of the following is true about the random variables x, y, and z? Check all that apply. So, roughly 8% of white males have some form of colorblindness, while the incidence among white females is only 1%. A random sample of 20 white males and 40 white females was chosen. Okay, so binomial. Binomial is a special type of probability distribution that meets 4 certain conditions. So, if in your experiment you have 2 outcomes, success or failure, if you have the same probability in each trial of, it's consistent. So in this case, the probability of being colorblind doesn't change. So we have 2 outcomes. The probability of success and failure is the same. All the trials are independent, meaning one does not affect the other. And that's important there. All of these conditions have to be met. But, sorry. I feel like I'm getting sick, so I keep pausing to drink my coffee. But, anyway, so we have that there are 2 possible outcomes, success or failure. The probability of success is the same for every trial. The number of trials is prefixed, and then each observation for each trial is independent of the other one. In this case, though, it meets. So with x, the number of males out of 20. So we have 20 males, and the probability of success is 0.8, and either you have color blindness or you don't, and one male having color blindness does not affect. Same thing with the females, though, or same thing with y, but y is females. So now we're looking at out of 40, there's a probability of success is 0.1. Oh, let me save. Okay. Where are we? Okay. Oh wait, no. And then y is binomial with n20. Okay. And z is not binomial. Z is the total number of colorblind individuals in the sample, males and females together. The probability is the same. Let's see. 8% of males have some form of colorblindness. Well, we don't know the probability of just being colorblind in general. Let's see. I guess it's 0.9. If we're looking at just white. I'm going to say that that's not true. Z is colorblind. Alright, number 66. Alright, so I'm actually going to go back real quick and say that Z is not binomial because the probabilities are not the same for every individual. So if you consider males and females together, the probability of them having color blindness is not the same because you could get a male or a female, and the probability is going to change between 8 and 1%. Alright, that's, the same. I'm not going to do that one. Just check them as the 4 conditions. Alright, so 67. Probability using binomial. So there are 2 functions in Excel, first of all, that calculate binomial probabilities. Binom diff. And you'll notice it asks for four things: the number of successes, the number of trials, the probability of success, and what's called a cumulative. And I'll talk about that in a second. So in this question, what is the probability exactly 2 of the 20 males are colorblind? So that's the number of successes we want. 2 out of the 20, the probability of having colorblindness for a male is 0.08. Now, cumulative, there are two types of probability that Excel will calculate. One is the probability that x equals a value, or the probability that x is less than or equal to a value. So, whenever we want just plain old equal to, we specify the cumulative is 0. We don't want cumulative, or else it will calculate the probability x is less than or equal to 2. But we just want equal to 2, so we just specify 0. Oops. So we get 0.271. Okay. In the following random experiment, talking about a variable x is binomial. Approximately 1 in 10 people are left-handed. Let x be the number of people that are left-handed out of a sample of 200. Although the individuals are sampled without replacement, it is assumed that we are sampling from the vast population. Okay. So this is binomial because we have two outcomes. You're either left-handed or you're right-handed. The number of trials is 200. We are sampling from a vast population, so everything is basically independent of one another. So that is going to be our binomial random variable. And they're independent. A sample of 4 cards is selected without replacement. Is it binomial? No, because without replacement automatically implies that they're dependent. Next question. Blood type AB occurring in only 4% of the population in the United States and in 1.5% in Australia. What is probably exactly 2 of the U.S. residents? So we go binomial disk. We want exactly 2, so our cumulative is 0. So 2 out of how many people in the U.S. are we sampling? 50 U.S. The probability of success in the United States is 0.04, and we want cumulative of 0, 0.276. Okay. Determine if the settings are binomial or not. A couple decided to continue having children until their first girl is born. X is the total number of children the couple has. So, probability of having total number of children. Probability of success is the same. However, the number of trials is not the same. The number of trials ahead of time is not fixed. So letter A is not binomial. You observe the sex of the next 20 children born in a local hospital. X is the number of girls among them. That is binomial, assuming that the probability of girl and boy is still 50%. C. You inspect each item classified as poor, satisfactory, or good. That's not binomial because it has more than 2 outcomes. With binomial, it's just success or failure. An engineer chooses a simple random sample of 10 switches from a shipment of 10,000. Suppose 10% of the switches in the shipment are bad. The engineer counts the number of X of bad switches. That's binomial. We're going to assume, because it's 10,000, each switch being defective or bad is independent of the other one. Our sample size is fixed at 10. The probability of success is 10%. And it's either bad or good. All right. Probability calculations. Now, there's a lot of questions on calculating probability with binomial, and the only reason why I did that is because it is really important that you get used to how to calculate these in Excel. So, according to government data, 36% of employed women have never been married. Round to 4 decimal places. If 15 employed women are randomly selected, what is the probability that exactly 2 of them have never been married? So, binomial disk. I don't know why it's exactly 2 every time, but exactly 2 out of the 15, but then the probability of success, or the probability of being never having been married is 0.36. And because we're looking at exactly 2 having never been married, our cumulative is 0. Rounding to 4 decimal places, 0.0411. Now, at most 2 having never been married. At most 2 means no more than 2. That means none are married, 1 married, or 2 married. So that means we're going to change our cumulative to 1. That means we want the probability that x is less than or equal to 2. So 0.0528. Now, the probability that at least 13 has been married. So at least 13 is greater than or equal to 13. Understand, please, that in Excel, the binomial dist function with a cumulative of 1 only calculates less than or equal to probability. We want greater than or equal to 13. So we need to be careful and say that this is, another way of writing it is, 1 minus the probability that x is less than or equal to 12. Think about it for 2 seconds. Whenever we do probability with binomial, we always want to rewrite it in terms of some less than or equal to probability. So for greater than a 13, including 13, we can just say it's the complement of all less than or equal to 12. So in Excel, that's what we're going to do. 1 minus binomial dist, the number of successes is 12. I know we're looking at 13, but we're doing it in terms of this complement. 12. The number of trials is 15. Please note that I italicized one part of it that says have been married, because that 36% is the probability of never having been married, so the probability is going to be now 1 minus 0.36. And our cumulative is once again 1. And we get 0.0528. Same thing. All right. How many more are these? Okay. Assume that 46% of people are left-handed. If we select 5 people at random, find the probability of each outcome described below, rounded to 4 decimal places. There are some lefties. Well, think of the same problem as before. Greater than or equal to 1 is the same thing as 1 minus x is not equal, or x is equal to 0. So we're going to do binomial dist. Number of successes is, actually we put 1 minus first. 1 minus. The number of successes is 0. The number of trials is 5. The probability of success is 0.46. And our cumulative is 0 because we're only looking at the probability that x is equal to 0. 0.95 or 1. There are exactly 3. Binomial dist, exactly 3 means our cumulative is equal to 0. So the number of successes is 3 out of the 5 trials. The probability of success is 0.46, and our cumulative is 0. Round it to 4 decimals, 0.2838. There are at least 4 lefties. So at least 4 lefties, greater than or equal to 4. Think about how we rewrote that in the last example. That's 1 minus the probability that x is less than or equal to 3. So now our probability statement is going to be in terms of 3 and not 4. So 1 minus binomial dist. The number of successes is now 3, once again, but out of the 5, 0.46, but now our cumulative is 1. 0.1415. No more than 2? Well, that's good because that's just equal to less than or equal to 2. That's by definition what binomial dist will calculate. So we just do 2 out of the 5, 0.46. Cumulative is 1. 0.5747. And if you can't see that, though, just always round using the Excel. Okay. The next 2 questions deal with the mean and the variance of a binomial random variable. And there are 2 formulas for it. They're on your formula sheet. The mean is just n times p, and the variance is n times p times 1 minus p. So, and it should make sense, meaning if we're selecting 5 people how many should we expect to be left-handed? Well, that's going to be 5 times 0.46. 230. Oh, 0.46. 2.3. And then standard deviation. So we're going to combine the variance and then do the square root of that. So the variance is n times 0.46 times 1 minus 0.46. That's the variance. We need to find the standard deviation by taking the square root of that number. Rounded to 4 decimal places. 1.1145. Okay, I'm not going to do number 75. It's the same thing. Exactly 2 students. Binomial diff with a cumulative 0. Okay. In its monthly report, the local animal shelter states that it currently has 26 dogs and 19 cats available for adoption. Alright, let's just do this. Let's do... Alright, so dog... I'm going to make a table. Dog, cat, male, female, total. I'm going to need to make a table. So, it's 26 dogs and 19 cats. So for a total of, how many animals? 45. 9 of the dogs are male, and 1 of the cats are male. Okay? That means we have a total of 10 males. That means we have 35 females, 18 female cats, and then how do we get this one? We just do 26 minus 9, 17. So we want the probability that the pet is male given that it is a cat. So that means, think of your conditional probability formula. This is the probability of being male and cat. Actually, no, this is going to be easier. We want the pet is male given that it is a cat. So given means that we know that the animal that we are choosing is a cat. We know that. How many animals are cats? 19. Hey, now. How many of those 19, though, are males? 1. 2 decimal places. 0.05. The pet is a cat given that it is a female. Pet is a cat given that it's female. Well, that tells us we know the pet is female. How many females are there? 35. How many of them are cats? 18. And the pet is a female given that it is a dog. So how many dogs are there? 26. Just look at that first column. 26 dogs, how many of them are female? 17.65. Alright, this is kind of the same one, right? It's going to be very, very, very similar. I already made the table for you with that one. Alright, 78. Suppose that the probability of an event A is 0.11 and the probability of event B is 0.39. Also suppose that the 2 events are independent. Another question just like this. Then the probability of A given B is the probability of A, which is 0.11. They're independent. Okay, the probability of a tourist visiting an area cave is 0.65 and of a tourist visiting a nearby park is 0.51. The probability of visiting both places on the same day is 0.43. The probability that tourists visit at least one of these places is blank. Well, at least one means either or. Oh, let me save really quick. Alright. So, where are we? Man. Number 79. Okay. Alright, so back to this one. That means at least one of these 2 places means the area cave or the nearby park. So we know that our OR formula is probability of a nearby cave plus the probability of a nearby park minus the two of them together, 0.73. Okay. In your top dresser drawer are 6 blue and 12 gray socks, unpaired and mixed up. One dark morning, you pulled 2 socks from the drawer, without replacement, of course. What is the probability that the 2 socks match? So 2 socks match means there are 2 situations that can occur. That means you get 2 blue or 2 gray. And that means that that's going to be based on our OR formula. That's going to be 2 blue plus the probability of 2 gray. And we can't, because we're not pulling, you can't have 2 blue and 2 gray. We're only pulling 2 socks. So now we just got to think of, all right, without replacement. So let's just focus on the 2 blue. What's the probability that you pull 1 blue? Well, there are 6 blue socks total divided by the total number of socks, 18. So you pull a blue sock, you keep it without replacement. Now you're going to go back in and grab another one. What's the probability that you pull out another blue sock? Well, you've already kept one, so there's 5 left out of 17. That's just the probability of getting 2 blue. Now we need to do 2 gray, so plus. So, same idea. 12 gray, so your first pull is 12 of them out of the 18. But then now you are, you've kept one. Now there's 11 gray left out of 17. And then rounded to 4 decimal places. 0.5294. All right. Colorblindness, okay. They're binomial. X and Y are both binomial. This question was up there before. And the other thing you see is, can we approximate this by a normal random variable? So, in order to approximate a binomial distribution with a normal distribution, 2 conditions have to be met. N times t has to be at least 10, and n times 1 minus t has to be at least 10. So we take, for both of these, n times t. So for x, it's the male. So we have 20 times 0.08, n times t, 1.6. So, nope, that doesn't work. So x can't be. Now let's do the females. So a random sample of 40 right males and 40 right females. So for females, it's n times t, or 40 times 0.01. I didn't do an equal sign again. 0.4. That's not 10, so neither x nor y can be approximated by a normal random variable. All right. Next one, 82. Almost done. 21 more questions. X is the number of males out of 100 who are left. Y is the number of females who are left. Z is the total number of left-handed individuals in the sample. So we know that Z is not binomial, so we don't need to focus on it. But we just need to calculate n times t and n times 1 minus t for both problems. So for x, out of 100, so that's going to be 100 times it says 12%. 13% of males. So 100 times 0.13 is 13. That's greater than 10. And then for the other one, we're going to do 100 times 1 minus 0.13. 87. So x can be well approximated by a normal random variable, as both of these are greater than 10. Now we do the same things for the females. We're going to do n times t. 80 times 0.11. 8.8. So it automatically tells you that y cannot be, so only x. Alright. 83. Suppose the time to complete a 200-meter backstroke swim for female competitive swimmers is normally distributed with a mean of 141 and a standard deviation of 7. Suppose that to qualify for the nationals, a woman must complete the 200-meter backstroke in less than 128 seconds. What proportion of competitive female swimmers will qualify for the nationals? So, We're moving on from binomial to normal, and just like there was with binomial, there's a norm-dis function. But norm-dis has two options, norm-dis and norm-s-dis. If you standardize a value, meaning you find the z-score, you use norm-s-dis. The S stands for standardized. But because we're given all the information, we're just going to use norm-dis. You don't have to standardize. So norm-dis calculates, just like with binomial, less than a value. Now, because normal distributions are continuous, less than or equal to and less than are the exact same thing. That is not true with binomial. Binomial is a discrete random variable, discrete distribution, so the inequality matters. With continuous, like normal, it does not matter. So we want, because it's less than 128, we're going to type 128. The mean is 141. The standard deviation is 7. And the cumulative is always 1 with normal. Always 1. Don't have to worry about that 0, 1 thing. And there we go. And we want 4 decimal places. Just save it. 0316. I'll save it. Suppose the time, same thing, but what is the completion time for a 200-meter backstroke for a female with a z-score of negative 1.64? So, our z-score formula is x minus mean, I'm going to say u for mu, divided by the standard deviation. In this question, it wants us to solve for x, given z, mu, and standard deviation. So, if we just solve that for x, we get that x is equal to the standard deviation times the z-score plus the mean. This is algebra. And we know all this stuff. We know that the standard deviation is 7, the z-score is negative 1.64, and the mean is 141. So it's 129.52. Suppose that scores on an exam are normally distributed with a mean of 75 and a standard deviation of 8. What is the exam score for an exam whose z-score is 1.25? So same thing. We're going to take the z-score, 125, multiply it by the standard deviation, and add the mean. 85. The z-score is to tell you how many standard deviations away from the mean the value of x is. So a z-score that's negative is to the left of the mean, and z-score to the right of the, or z-score that's positive, I'm sorry, is to the right of the mean. All right. Suppose the time to complete a 200-meter backstroke swim for female competitive swimmers is normally distributed with a mean of 141 and a standard deviation of 7. Suppose that the fastest 6% of female swimmers in the nation are offered scholarships. In order to be given a scholarship, a swimmer completes 200 meter backstroke in no more than how many seconds? So in this case, the fastest 6% of swimmers were given the probability. The probability that x is greater than some value is 6%. But we need to figure out what the value of x is. We could use the z-score formula, but because we're given the probability and not the z-score, we can actually use another function in Excel called norm inverse. Norm inverse, you're given the probability. And that's what it asks for, probability. But the trick here, though, and the important thing to remember, is that because normal distribution probability calculations are always less than or equal to, norm inverse only works if you're given the probability that you're less than a particular value. We want the fastest 6%. So unfortunately, that means we want the slower 94%, or 1 minus 0.06. And the mean is 141, and the standard deviation is 7. And it tells you that the value is 151.88 or 152. Okay. Suppose the battery life is a normal random variable with mean 8, standard deviation 1.2. Using the standard deviation rule, what is the probability that a randomly chosen battery will last between 6.8 and 9.2? Well, look at the relationship between 8 and 1.2. If you add 1.2 to 8, you get 9.2. If you subtract 1.2 from 8, you get 6.8. That tells us that we're within 1 standard deviation from the mean. So the empirical rule, or the standard deviation rule, tells us that's 68%. Okay? So suppose the battery life is a normal random variable with mean 8, standard deviation 1.2. How likely is it that a randomly chosen battery lasts longer than 10.4? Well, 10.4 is 2 standard deviations away, and we know that within 2 standard deviations we have 95% of our data, which means we have an outside 5%. But we're looking for greater than one of those tails, so we divide 5% by 2 and get 0.025. That's from last unit. Okay, the number of days X after mail-out it takes a utility company to receive payment for a customer's bill is a normal random variable with mean 31 and standard deviation of 6. The latest 2.5% of bills will be received more than how many days after mail-out. And this is a multiple choice question, so this kind of involves the same thing. We have latest 2.5% of bills. So think of the empirical rule, the standard deviation rule. The latest 2.5% is what we just did. So that's 2 standard deviations to the right of the mean. So 31 plus 12. 12 being 2 times 6. So that would be 43. Okay. The probability is 0.997 that a bill will be received between which of the following number of days? Well, that would be 99.7% is 3 standard deviations. So we're going to take 31 and subtract 3 standard deviations. 2 equals 74. And then we're going to do 31 plus 3 times standard deviation. So 3 standard deviations in either direction is between 13 and 49. The number of days X after mail-out it takes a utility company to receive payment for a customer's bill is a normal random variable with mean 31 and standard deviation is 6. The probability is 0.5 that a bill will be received later than, well, think about the normal distribution. The mean cuts it into 0.5 and 0.5. So the mean is our value here, 31. All right. The number of days X after mail-out it takes the utility company to receive payment for a customer's bill is a normal random variable with mean 31 and standard deviation of 6. About 16% of the bills will be received earlier than blank days after mail-out. So you're looking to find what is the lower 16% according to the standard deviation rule. And if you remember, the lower 16% is 1 standard deviation to the left of the mean, so that would be 25. And if you're having trouble doing these, just think about that picture you drew. So we have the mean in the center, and we go 1, 2, and 3 standard deviations away. According to the Bureau of Labor Statistics, in May 2014, the mean hourly wage of a social worker was 28.08, with a standard deviation of 1.97. So Veronica is a social worker with an hourly wage of 31.6. What's her Z-score? So to find a Z-score, we just take our X value, 31.60, subtract the mean of the distribution, and we divide by the standard deviation, 1.97. 31.6, 1.97. So that's going to be 1.79. And we know it's positive because 31.6 is greater than 28.08. The time it takes a surgeon to complete a laparoscopic surgery to remove the gallbladder is normally distributed with mean 132.4 and a standard deviation of 15.7. A patient's risk of complications is increased the longer the patient is in surgery, and unusually risky surgery is one that is in the top 4%. So when is the surgery considered unusually risky? Well, we're given the probability, top 4%, so we're going to use norm inverse to work backwards. But remember, do not type in 0.04 here, because this calculates the lower 4%. So we need to know if we want the upper 4%, we want the lower 96%. Well, minus 0.04. Mean is 132.4, and the standard deviation is 15.7. So it's 159.8858, 159.9 minutes. The lifetime in miles of a certain brand of tire is normally distributed with a mean of 22,000 miles and a standard deviation of 3,100. The tire manufacturer wants to offer a money-back guarantee so that no more than 3% of tires will qualify for a refund. What is the minimum number of miles the manufacturer should guarantee that the tires will last? So we want no more than 3% will qualify. So that means that we want no more than 3% will last less than 22,000 miles. So we want to specify they need to guarantee what number should they guarantee so that the tires will last. So we want no more than 3%. So that means less than or equal to 3%. So we want to do norm inverse, no more than 3%, so 0.03. The mean is 22,000, standard deviation is 3,100. And we get 16,169 or 16,170. Okay, the distribution of the diameters of a particular variety of orange is approximately normal with standard deviation 0.3. How does the diameter of an orange at the 67th percentile compare with the mean diameter? Well, this one's a little tricky. So what we know, though, is how does the diameter of an orange at the 67th percentile compare with the mean? So what we first want to do is figure out what is the z-score for an orange at the 67th percentile. Well, definition, 67th percentile means this orange is bigger than 67% of the other oranges. So probability is going to be 0.67. The mean is, we don't know it yet. So all we can do is find the z-score, which means the mean is 0 and the standard deviation is 1. So that's the z-score for an orange at the 67th percentile. So what we can do, though, is use the definition of z-score and just solve for the numerator, x minus the mean, because that's going to tell us, really, the relationship between the mean and the value of x. So all we have to do is say that x minus mu is equal to z times the standard deviation. So if we do that, we get the z-score times the standard deviation of 0.132. So this tells us that the value of x minus the mean is 0.132. So the value of x is 0.132 inches higher than the mean. And there we go. The heights of students at a college are normally distributed with a mean of 175 and a standard deviation of 6. One might expect in a sample of 1,000 students that the number of students with heights less than 163 is what? So we need to first find the probability that we're less than 163. So norm diff, remember norm diff calculates less than probability automatically, so we just type in the numbers. Less than 163, where the mean is 175, the standard deviation is 6, and the cumulative is always 1. So that tells us our probability. To get the expected number, we just take the probability and multiply it by the sample size. So 1,000 times this probability. About 23 people. The weights of cockroaches living in a typical college dorm are approximately distributed with a mean of 80 and a standard deviation of 4. The percentage of cockroaches weighing between 77 and 83 per grams is about blank percent. So we're going to have to convert this to a decimal, or a percentage. Now, when we want the probability between two values, we can write it like this. The probability that we're between 77 and 83. But how do we use the normal distribution, norm diff function in Excel? To do that, we have to rewrite this to be the probability that x is less than 83 minus the probability that x is less than 77. And taking this difference is going to leave the area or the probability between these two values. So in this string of code, we're going to do two norm diff values. We're going to do norm diff less than 83, where the mean is, okay. Where the mean is 83, or no, I'm lying, where the x is 83, but the mean is 80, standard deviation of 4, cumulative always 1. And then just do minus, then do it again. Norm diff, x is now 77, mean 80, standard deviation of 4, cumulative is 1. 0.54, okay, whatever. But then we're going to take this and multiply it by 100 and convert it to the closest decimal, which is 55%. Okay, the following displays two normal distributions. Which of the following are true? The mean of A is less than B. That's true. The standard deviation of A, let's save it really fast. We are almost done and we don't want this to all reset. Okay. Going back. So the mean of A is less than the mean of B. Well, the mean of A is less than B. You can see that here. Here's A, here's B. The standard deviation of A is less than B. That's also true. Remember, standard deviation refers to how far the values typically are from the mean. And the area under the curve of A is less than the area under B. That's not true. If they're normal distributions, the total area under the distribution is 1 for both. It doesn't matter what they look like. So only 1 and 2 are true. The run times of a marathon runner are approximately normally distributed. The z-score for his run this week is -2. Which of the following statements is the correct interpretation of the z-score? So this week, because it's negative, this week his time was 2 standard deviations lower than his average time. That's the definition of the z-score. How many standard deviations you are below or above the mean. All right, 101. The distribution of scores in a recent test closely follow a normal distribution with a mean of 22 and a standard deviation of 2. What proportion of students would at least 19 points on the test? So, at least 19 is greater than or equal to 19. But our norm distribution calculator only does less than, so we need 1 minus the probability that x is less than 19. So we're going to use 1 minus norm diff x is 19, the mean is 22, standard deviation is 2, its cumulative is always 1. Round to 5 decimals, 1, 2, 3, 4, 5, 6. Well, there we go. 0.93319. What is the 63rd percentile? Well, we're going to use then norm inverse and say we want to know what's the value of x that has a probability below it as 0.63. Our mean is 22, and our standard deviation is 2. Rounded to 3 decimal places is 22.664. All right. The EPA requires that the exhaust of each model of motor vehicle be tested for the level of several pollutants. The level of oxides of nitrogen in the exhaust of one light truck model was found to vary among individual trucks according to a normal distribution of mean 1.45 and standard deviation of 0.4. What is the 30th percentile? All right, well, that's easy. Norm inverse. Nope, not norm diff. Norm inverse. Probability is 0.03. The mean is 1.45. The standard deviation is 0.40. And then enter. And we want to round it to 4 decimal places. 1.2402. What is the IQR? Interquartile range. Well, this is a good question. So if you remember, IQR is the difference between your third quartile and your first quartile. Now, the first quartile, Q1, has another name. It's the 25th percentile. Q3 has another name. It's the 75th percentile. So to find the IQR, we're just going to find the difference between our 75th percentile and our 25th percentile. So 75th percentile is a value of x where there's a probability of 0.75 below it, with a mean of 1.45, and a standard deviation of 0.4. That's the 75th percentile, or Q3. Now minus, do it again, norm dot inverse. Probability is now 0.25. Mean of 1.45, standard deviation of 0.4. And it's enter. And there it is. Rounded to 4 decimal places. 0.5396. Yay, we're done. Almost. One question. A study was made of seatbelt use among children who were involved in car crashes that caused them to be hospitalized. It was found that children not wearing any restraints had hospital stays with a mean of 7.37 days and a standard deviation of 1.5 days with an approximately normal distribution. Find the probability that their hospital stay is from 5 to 6 days, around to 5 decimals. Well, just like this one here, this is going to cause us to have two different normal distribution calculations. Norm diff, take the larger, 6 days, mean is 7.37, standard deviation of 1.5, and then 1. This finds the probability less than 6, but we want to stop it at 5. So we're going to do minus norm diff 5, 7.37, standard deviation of 1.50, and a cumulative of 1. And we're going to round this to 5 decimal places. 1, 2, 3, 4, 5. 0.1, 2, 3, 4, 8. Find the probability that their hospital stay is greater than 6. Well, norm diff only calculates less than, so we can calculate this. Greater than 6, the same thing as probability of less than 6. 1 minus the probability of less than 6, I'm sorry. So, we're going to do equal to 1 minus norm diff less than 6. So 6, 7.37, standard deviation of 1.5, always cumulative. And round to 5 decimal places. 1, 2, 3, 4, 5. 0.81947. And that concludes it. Let's see if I made any mistakes. Now, granted, it's not going to be 100% because I did skip a bunch of questions. It's taken a while. Here we go. 81%. Let's hope that it's because of all the questions that I skipped. Yeah. Let me see. Suppose Joan has a 4-sided die that was size of number 1, 2, 3, and 4. After she rolls it 24 times, Joan finds that she rolled the number 4 a total of 4 times. What is the empirical probability that she rolls a 4? Oh, oops, you know what? I was thinking of theoretical probability. So to get that one, she rolls a 4 times out of 24. So your empirical is the same thing as your experimental. So 4 out of 24 times is 16.67. So I'm sorry, that one should be D. So experimental probability and empirical are the same. I was thinking of theoretical. I didn't answer that one. Oh, I meant A. I talked about this. It should be A. This calls into question the validity. I just wasn't reading. This is what I said the answer was going to be, but I clicked D instead. So the answer is A. But if you go back to this question, I do say that this probability was like 9%, where it should be 25%. So the die is probably not fair. I clicked the wrong button. 1, 2, 3, 4, 5, 6, 7, 8. What is the sample space? Why is that wrong? Alright, so I didn't read this very well. I'm sorry. I'm also getting sick. I don't know if you can hear me because I keep coughing, but he plays until he wins a game. So once he wins, he stops. But he won't play more than 3 games. So that means the sample space is going to be him winning and then stopping. He's going to lose 1 game and then win, so he stops. He's going to lose twice and then win, or he's going to lose all 3. So actually, the answer to this question is A. I'm sorry. This is just all possible outcomes if he just was playing 3 games, but not stopping. But it does say until he wins a game. So it is win, lose, win, lose, lose, win, lose, lose, lose. I didn't do that one, I didn't do that one, I didn't do that one. All of these are good. Of the friends who like chocolate, which of the following probabilities you need to find in order to determine the proportion who like chocolate that also likes sprinkles? there's some issues with this question based on the wording. We've had issues with this one. So, which of the following probabilities you need to find in order to determine the proportion of friends who like chocolate that also like sprinkles? Well, you can interpret this two different ways. So, don't worry about this one being on a test, because the way that I interpret it is who likes chocolate given that they like sprinkles. But I'm assuming that they also would mean that chocolate and sprinkles. So don't worry about that one being on the test. Which is one is true. The number of students in the class is discrete. The average age of these students in the class is continuous. The room number is continuous. The average weight of these students is discrete, and a student's GPA is... So I guess with this question what they wanted was to say that the average age in the class is continuous because, you know, theoretically, now that I think about it, if you calculate the age, you could always specify it as the number of months, the number of days, the number of hours, the number of minutes, the number of seconds, milliseconds, all that stuff. So they're kind of going a little bit finer than just saying your age is 10, 11, 12, 13, 14, 15, 16, you know, those exact values, but you could always get finer and finer. So the average age of students in the class is continuous would also work out. And then a GPA is continuous in a sense that, you know, it's not just going to be like 3.1, 3.2, but you could always get finer and finer and finer and finer. 3.112, 3.11112. So in this case, you would want to check A, B, and E and say that the average age is continuous because you can get finer and finer and finer measurements. And that same reasoning is also true for the GPA. I didn't do that one. Didn't do that one. Didn't do that one. I didn't do that one. Why did this one get marked incorrect? Part 2. There are exactly 3 lefties in the group out of 5. So, rounded to 4 decimal places. Where is that question at? Well, let's see. Let's just do it again. So, binom dist, exactly 3 is 3, 5, 0.46, 0. They're exactly 3. So 0.2838 is the right answer. So there was just a mistake in the coding somewhere. The right answer is 0.2838. So I'll go back and look at that one. Round up to 4. I'll go back and look. I didn't answer that one. I didn't answer that one. What? Oh, I know what's wrong with this one. So this problem is correct. It is 0.0316. But what it wants is it has the answer based on a table. And so the answer from the table is going to be slightly different. But don't worry about that. Don't worry about questions like that. There's going to be no questions in the test that require you to use a table. And we could even just look real quick, just so you can see what the answer technically is exactly, or 0.0316 is exactly. So it's going to be, we want to find the probability x is less than 128, so we must find the z-score for 128. So 128 minus 141 divided by 7. So the z-score is negative 1.85. So if we go to this table, negative 1.85, so that's going to be 0, okay. So 0, 1, 2, 3, 4, 5. So the table is 0.0322. But exactly is 0.0316. We're close. The table's an approximation. So just, it's okay. That's normal. Same thing here. They probably wanted you to use the table and not the and not the rounded decimal. Same idea. Alright. So I'll go back in and look at that binomial question. Other than that, I hope this has helped you with the test review, and just know that, as always, we are always here to help you with these questions, and good luck on test 2.